Everybody, in this video, we're going to talk about how you can use tables, graphs, and equations to help your students solve proportional word problems. So let's say, for example, that we have a set of building blocks and there's 5 yellow blocks for every 2 red blocks. You could create a double number line with this if you wanted to. You could make your 2 number lines where one represents the number of yellow blocks, one represents the number of red blocks, and you could scale it accordingly. Or another way you can do it is you can set it up as a table. And you can say, I know that 5 yellow blocks corresponds to 2 red blocks. And if I double those numbers, I know that 10 yellow blocks also corresponds to 4 red blocks. Or if I triple it, 15 yellow blocks will correspond to 6 red blocks, 20 yellow blocks will correspond to 8 red blocks, and 25 yellow blocks will correspond to 10 red blocks. So basically, I'm just scaling these numbers. So like 5 times 2 equals 10 and 2 times 2 is 4. So that's why that's an equivalent ratio. Or 5 times 4 equals 20 and 2 times 4 equals 8. That's where I got those numbers. And so these numbers that I got in the table are communicating the same information that you would see on a double number line. It's just showing it in a different form. And we can also represent it on a graph. So a graph is essentially 2 number lines that are put perpendicular to each other. So rather than having parallel number lines like we did with the double number lines, a graph has them perpendicular to each other. And in this case, I'm going to have this number line represent the yellow blocks, and this one represent the red blocks. And so if I look at this ratio that I was given, and I know that 5 yellow blocks corresponds to 2 red blocks, the way that we show that those two things are matched up with each other or proportional to each other is by putting a point right here. And so that point represents the relationship that 5 yellow blocks corresponds to having 2 red blocks. And then you could say this point right here is 10 yellow blocks and 4 red blocks. So that would be this point. And then if I have 15 yellow blocks and 6 red, that would be 15 on the yellow number line, 6 on the red number line. And this point would represent that. And then if I have 20 yellow blocks and 8 red blocks, I would go to 20 on the yellow number line, 8 on the red number line, and represent it with this point. And your students might notice that there's a pattern here where all of these dots end up forming a straight line. And you can use that straight line to predict how many yellow or red blocks there might be for a number that's not in your table. So, for example, I might say, okay, what if I had like 12 yellow blocks? Well, if I had drawn this line perfectly, whatever this corresponds to would tell me how many red blocks. Now, in this case, this isn't the best example because, for one thing, I didn't draw my line straight. But also, the number of red blocks would be a fractional number. And it doesn't really make sense to have a fraction number of blocks. But if you had, money and time or miles and time, something where fractions do make sense to get fractional answers, then you could use a table to help your students predict numbers that are in between the scaled version of your ratios like we did here. So this is how you can teach your students how to create tables and graphs. And it's important to realize that all of these representations are all representing the same thing. They're all representing the multiplicative relationship between the number of yellow blocks and the number of red blocks. Whether it's a double number line or a table or a graph, it's all communicating the same information. It's just doing it in different ways. And there's an interesting relationship between the unit rates and the tables and graphs that you can create to represent the rates that the unit rates are equivalent to. So in our unit rate video, we talked about how there's always 2 different unit rates that you can use to represent a proportional relationship. So if you can grade 7 papers every 2 minutes, you can think about this as 7 papers for 2 minutes. And if you convert that to a unit rate, you find that you can grade 7 halves papers per minute. which basically means that you can grade 3.5 papers per minute. Or the other way you can think about it is that it takes you 2 minutes to grade 7 papers. And so that means that it takes you 2/7 of a minute per paper. So both of these unit rates are communicating the same proportional relationship. They're just looking at it in different ways. One of them is saying how many papers you can do every minute. One of them is telling you how many minutes it takes to do each paper. And this unit rate shows up in our table because if I wanted to figure out how many minutes it takes to do 7 papers, I could just multiply 7 by 2/7, which is this ratio here. Because if it takes me 2/7 of a minute to do 1 paper, then I can take the number of papers and multiply by 2/7 to figure out how many minutes that would be. And you can see that this is consistent across the table because 14 times 2/7 would equal 4, 21 times 2/7 would equal 6, and so on. And so you could use this pattern to find the number of minutes it would take to grade a number of papers that is not a multiple of 7. Because if you look at all of these numbers, they're all multiples of 7. But what if you wanted to figure out how long it would take you to grade 11 papers? Well, because of this unit rate pattern, I could just do 11 times 2/7, and that would tell me that it takes 22/7 of a minute to grade that number of papers, which would be a little bit more than 3 minutes. And so this unit rate pattern can be used to write equations. And you can say if I have my number of papers, whatever number that is, whether it's a multiple of 7 or a different number like 11, if I multiply that number of papers by the unit rate 2/7, because it takes 2/7 of a minute to grade each paper, that will tell me how many minutes it takes to grade that number of papers. So this would be one equation that represents this proportional relationship. You could also do it in the opposite order, though, because if I multiply 14 by 7/2, that tells me how many papers I can grade in 14 minutes. And that's using this ratio here, or this unit rate, because this one is telling me that I can grade 7/2 papers per minute. And so if I take the number of minutes and I multiply by 7/2, that will tell me the number of papers. And so that equation would say that if I do the number of minutes and I multiply by 7/2, that tells me how many papers I can grade in that amount of time. So both of these equations represent the same proportional relationship. They just are describing it in different ways. And one equation, like this red one, would be useful if you knew how many papers you needed to grade and you were wondering how many minutes it would take, versus the green equation would be more useful if you knew how many minutes you had and you wanted to know how many papers you could grade. So both of these equations represent the same relationship. It's just dependent on which one's more useful. It's also kind of interesting to note that the unit rate shows up in the graph as well. Because if I look at this unit rate 2/7, basically what that's communicating is this point right here, because that's telling me that I can grade 2/7, or sorry, it takes 2/7 of a minute to grade 1 paper because this is my minute number line and this one is my paper number line. So that shows up in the graph there. And so does this 7/2, because that would be this point right here. Oh, sorry, not actually that one. This one right here. Because that's saying if I have 1 minute, then that corresponds to 7/2 of a paper. And then the other place that the unit rate shows up is in the slope of the line. So you won't be teaching this concept to your elementary school students, but it's helpful for you to know, especially if you do end up teaching middle school. Because if you look at the slope of the line and you look at the rise over the run, well, the rise is 2, the run is 7, and the slope, 2/7, corresponds to that unit rate. So that's another way that the unit rate will show up in your graph. So that's just a quick overview of how you can use tables, graphs, and equations to represent proportional relationships. And again, the important thing to realize is that all of these different representations are representing the same relationship. They're just different ways of expressing it, and the different methods are useful for different situations. So if you have any questions, let me know, and I hope you have a great day.